engineers concocted the particular shutting down of insignificant frameworks. They were constrained into making this hard choice. Thus, they utilized a foundational way to deal with identify and deactivate parts or subsystems that are not essential for the shuttle's mission targets. We see proof of this when we investigate the Wolmers related to specific instruments that must be turned off. These radiators were initially intended to maintain the instruments at specific temperatures, so they were operated at optimal performance. However, the story has been revamped by enacting them significantly to reduce power consumption on board the Explorer. This decrease in the spacecraft's power usage comes with a widespread influence, an increase in the Explorer's life expectancy. It's a mutually beneficial arrangement for everyone. We ought to bear in mind that the decision to shut down insignificant systems isn't taken lightly. It is a planned movement that requires careful assessment of the compromises between power conservation and the scientific objectives of the spacecraft. Whenever such a decision is made, all hands must be on deck. Engineers and researchers need to sit together and assess the impact of deactivating specific systems on the quality and availability of scientific data. Feelings aren't influencing everything here, it is strictly business, based on the realities at hand. The team is driven by the desire to maximize power efficiency while maintaining the essential functionality of the shuttle so it can continue to gather vital data about our universe. Under this pressure, engineers and researchers alike believe that nothing should frustrate the Explorer's mission when it comes to revealing the profound mysteries locked away in the secret domains of space, mysteries that the universe has been withholding from us for centuries. However, power reduction isn't the only way that NASA engineers are keeping the Explorer functioning optimally in space. They had another ace in the hole to support the rocket alongside researchers. The engineers needed to develop power management strategies that are adjusted to the ever-changing conditions of the shuttle's environment. For example, as Explorer 1 voyages farther away from the Sun, the available solar energy experiences a decline. This is indeed a problem. However, the specialists came prepared, compensating for this developing threat by ensuring that the rocket adjusted its power consumption accordingly. This adaptive approach is a triumph for NASA engineers and scientists since it guarantees that the available power resources are efficiently allocated to support the spacecraft's critical activities and data transmission back to Earth. Curiously, the good news doesn't end here. There have been ongoing technical advancements and upgrades in power management that have allowed scientists to refine and improve the power systems of the rocket over the years. A close look at these improvements reveals that they include more efficient power distribution, advancements in battery charging techniques, and progress in power regulation and control. The implementation of well-thought-out power management strategies has opened an exciting doorway for engineers, making it possible to extend the operational life of Explorer 1, along with its twin, Explorer 2. This is a significant win for established researchers and the world at large. The careful allocation and management of power resources have equipped Explorer 1 with the necessary resilience to keep exploring the depths of space, unhinged and unafraid of failure. The rocket has embarked on a remarkable scientific journey, where its critical systems remain functional despite its advanced age, allowing it to send valuable data and provide insightful information back to the ground team on Earth for as long as possible. If we consider that the rocket wasn't designed to last more than 5 years, we can see what a tremendous achievement this is, one worth celebrating. The credit for this superlative performance of Explorer 1 rests solely on the dedicated hands of researchers and engineers. We cannot help but applaud their determined quest to ensure that the shuttle continues to operate optimally. They spend considerable time researching and assessing what unfolds in space to maintain the shuttle's ideal functionality. However, as much as we commend their efforts, we must not overlook that space is an unpredictable environment. Anything can happen there without warning, and some unexpected events may arise regardless of how prepared we may be. This new discovery of 500 obscure objects belongs to this category. No matter how we interpret what happens in deep space, nothing prepares us for the astonishing news that Explorer 1 brought back. Researchers stood by, and all they could see was that Explorer 1 was terrified. Perhaps these unexplored objects were heading its way with plans to attack the probe. When scientists received the alarming report from the explorer, everyone was thrown into a state of deep concern. An informal state of emergency was declared in the scientific community as analysts and engineers pondered a solution to this maze of an issue that unfolded right in their faces. This discovery was way outside the normal context. At best, the explorer was merely intended to communicate with meteoroids, asteroids, and comets during its journey through space. So, we can understand their confusion when the explorer coincidentally detected peculiar objects whose origins we could not place anywhere in the catalog of space phenomena we have compiled over the years. In fact, we could say that these obscure objects had appeared out of nowhere. The truly confounding part was the possibility that the objects could be heading our way. In the weeks that followed, researchers soon put this possibility to rest, never to rise again. Yet, they faced a tougher nut to crack. They needed to answer the question of why the explorer sent such distressing information in the first place. When scientists detected the unsettling data from the explorer, they treated it as a peculiarity. According to researchers, the term was the best description of the issue that the space probe had brought to their doorstep. They informed the public that the signals came in unexpectedly, with no clear way to sort out what was wrong. What happened was that Explorer 1 began transmitting puzzling telemetry data back to Earth. As if this weren't confusing enough, they were even more shocked by the fact that the rocket remained responsive to commands from. How would we make sense of these surprising readings? Despite the fact that the rocket was answering ordinarily, the main hiccup in this story is that there was a slight delay in communication. Generally speaking, researchers found it baffling that the Explorer 1's radio wire stayed highlighted on Earth, guaranteeing that it kept on getting and executing directions. Still, in the eyes of scientists, this event was ending up being a miracle, one that made them absorbed in the stream of stresses. There must be a scientific explanation for this peculiarity. They repeatedly contemplated how the spacecraft could be practically normal yet be sending back mysterious information to Earth. The story simply wasn't adding up. Researchers were more puzzled when they saw that the inconsistency hadn't triggered any fault protection systems. This was genuinely astounding since these onboard systems are designed to activate when anomalies are detected. These systems are intended to usher the spacecraft into an experimental mode that allows engineers to investigate and analyze the issue. An alternate story played out during this puzzling event. As the onboard security system remained put, and Explorer 1 continued its operations without entering experimental mode. At some point, researchers and specialists had to pinch themselves to be sure they weren't in a dream. They were in a real fix, with no idea of where to go. However, the ice of confusion that described this discovery soon began to melt as scientists kept exploring it, looking for a response. Their efforts paid off eventually, as they soon arrived at the golden gateway they had been watching out for. Scientists figured out that the peculiarity was connected back to the Altitude and Control Subsystems, ACCS. It turned out that the ACCS was the guilty party behind this anomaly. According to the Explorer design, the ACCS was tasked with precisely positioning the spacecraft and controlling its movements. Imagine the shock on researchers' faces when they discovered that the ACCS had been sending telemetry information through an onboard computer that had stopped working a long time ago. They could not believe their eyes as they found that this obsolete computer, which shouldn't have been involved in data processing, had by some phenomenal stroke of destiny found its way into the telemetry transmission process. Consequently, this led to the corruption of the data being sent back to Earth. This onboard computer had somehow made itself a hindrance in the transmission chain of information from the Explorer to Earth. However, what researchers still required was a response for why this unsettling event was happening in the first place. Why did the inconsistency spring up from nowhere? Despite the help from their new discoveries, their minds still wandered towards the possibility that the Explorer might have seen 500 obscure and confusing objects passing by in space. In an attempt to lay this chance to rest and reassure themselves, researchers formulated an exit plan. This plan involved instructing the ACCS to divert telemetry information to the suitable working data. They chose to go with this action because it was considered relatively safe, and their bet ended up being right in the end. Although the plan was effectively executed, they were confronted with another challenge: the critical time delay in communication. During this investigation, they were a bit stressed by this result. However, it wasn't a value thing wasting their time over. When we recall the immense distance that exists between the Explorer spacecraft and the planet, the gulf is so large that it is quite reasonable to expect some delay in communication. With a distance of 14.5 billion miles between the spacecraft and our dear planet, it takes a lot of time for radio transmissions to go through from both areas. This is how the communication between the two parties plays out. Whenever the Mission Control Team at NASA's Deep Space Network, DSN, sends an order to the Explorer, it goes as a radio transmission at the speed of light. The Deep Space Network is a broad network of enormous radio receiving antennas strategically located across the globe that makes it possible for NASA to maintain communication with spacecraft exploring the farthest reaches of our solar system and beyond. The primary goal of this network is to facilitate two-way communication between Earth and deep space missions, alongside conducting radar and radio astronomy observations to broaden our understanding of the universe. Whenever the Deep Space Network is sending data from the Explorer to Earth, it often uses its channel 18 and generally operates at frequencies of 2.3 GHz or 8.4 GHz. When we take another look at this, we find that while conveying messages from Earth to Explorer 1, a frequency of 2.1 GHz is used, and it occurs at the speed of light. As much as this traveling at the speed of light seems exhilarating, we should not forget the tremendous distance separating both the spacecraft and Earth. Hence, even at this supersonic speed, it takes the signal roughly 22 hours to reach the spacecraft. This means after an order is sent, the Mission Control Team must choose to sit tight for 22 hours before getting any confirmation or response from the Explorer spacecraft. This time delay explains why the mission team is extremely meticulous regarding the orders they send to the Explorer. They are careful not to make any mistakes since it would extend their waiting time. They often spend hours reviewing orders and going over plans before sending them to avoid issues and unnecessary delays. Time delays would prolong the period required to diagnose irregularities, such as the one recently discovered by Explorer 1. Although the popular theory is that the telemetry data sent to Earth was likely caused by the ACCS receiving a faulty command from an onboard computer, specialists are far from satisfied. They believe that there is still something missing to complete this puzzle. Some scientists remain uncertain about the specific cause of this anomaly, as there are various possible factors, such as radiation, extreme temperatures, and micrometeoroid impacts. The universe's environment can be a very unforgiving adversary, even for sophisticated spacecraft like Explorer 1. Additionally, since the Explorer spacecraft is aging, it may have been a victim of the harsh and unforgiving space climate. All we can do for the time being is keep our eyes glued to all these possibilities, as researchers may ultimately determine which one of them is the culprit. Moreover, let's cross our fingers for the next exciting discovery that Explorer 1 will unveil as it continues to blast through the deepest parts of the universe.